What's going on, guys? Your everyday math tutor here, and in today's video we're going to be going over the product and quotient rule. Okay, so what the product rule states is we must multiply f of x, take the derivative of g of x, add g of x times the derivative of f of x, and this is the product rule. So now let's take a look at some examples using the product rule. The first example we're going to have is y equals to x times e to the power of x. And now using the product rule, first we have to define what is f of x and what is g of x. So our f of x is going to equal to x, and our g of x is going to equal to e to the power of x. So now using the product rule, also really quickly, we could use the product rule that looks like this: f of x times g prime of x plus g of x times f prime of x. We can use that rule as well. I think moving forward we'll use this instead. So what we'll have now is that f of x is going to equal to x times g of prime of x is now e to the power of x prime plus g of x, which is e to the x, and then f prime of x is just x prime. And now we just take the derivative, and we're going to have e, or x times e to the power of x prime, which is just e to the power of x, plus e to the power of x times x prime. X prime is just multiplied by 1, so we will have x times e to the power of x plus e to the power of x. Now you could factor out the e to the power of x and just have x plus 1 inside the parentheses, and this will be your final answer. All right, let's take a look at the second example here. Again, I like to write down my product rule just so I could see a little better what I am going to be taking the derivative of and where I'm placing them. So first things first, define what f of x is, and that it will be x cubed, and then g of x is going to equal e to the power of x. Now I can substitute those into the product rule. My f of x will be x cubed, and I'll be taking the derivative of e to the power of x prime plus g of x, which is e to the power of x, and then taking the derivative of x cubed. So we'll write that as x cubed prime. And now we just take the derivative and simplify. So we're going to have x cubed. The derivative of e to the power of x is just e to the power of x plus e to the power of x times the derivative of x cubed, which is simple. That's just 3x squared. So we'll have x cubed times e to the power of x plus 3x squared times e to the power of x. Again, you can factor out an e to the power of x and just have x cubed. We'll have parentheses instead. We'll have x cubed plus 3x squared inside the parentheses, and this could be your final answer. Let's do this final example using the product rule. So we'll define f of x as x cubed plus 2, and g of x is equal to x plus 4. Again, rewrite your product rule so you could memorize it. I'm trying to erase this. The only one thing I hate about Apple Pencil is that you can't just flip the pen and erase. It's not like the Microsoft Surface products. But anyways, we have g of x times f prime of x. And now my f of x is going to be x cubed plus 2. I'm going to be taking the derivative of x plus 4. So that will be x plus 4 prime plus g of x, which is x plus 4 times x cubed plus 2 prime. All right, so now we simplify and take the derivative. So we're just going to have x cubed plus 2 times the derivative of x plus 4, which is just 1. So we multiply by 1 plus x plus 4 times the derivative of x cubed plus 2, which is just 3x squared. Okay, so now we have x cubed plus 2 plus, we'll use the distributive property to distribute that 3x squared to every term inside the x plus 4 parentheses. So we're going to have 3x cubed plus 12x squared. And now we just combine like terms. I see here that we have 2x cubes. So we have the 3x cubed plus the x cubed, which is 4x cubed. And that's all we can combine. So we're just going to rewrite the final terms as 12 x squared plus 12x squared plus 2, and this is our final derivative. All right, so let us now go over the quotient rule. So let's write that down, the quotient rule. Change the color here. Quotient rule. And what we have for the quotient rule is the derivative of whenever we have a function divided by another function here, g of x or f of x divided by g of x, we are going to have to take the, let me take this out real quick. So what we'll do is have g of x here in the outside. And what that looks like is g of x times f of x or f prime of x minus f of x times g prime of x over g of x squared. So essentially what we're doing in the numerator is taking the derivative of f of x and multiplying g of x, then subtracting f of x times the derivative of g of x over g of x squared. All right, so here we have the first example using the quotient rule. So here we're going to establish that f of x is equal to x and g of x is equal to e to the power of x. Put that a little bit more up here. All right, so using the quotient rule, again, I like to rewrite my quotient rule as g of x times f prime of x minus f of x times g prime of x over g of x squared. We just rewrite it just so we could memorize it afterwards. Okay, so now that we've rewritten our rule, we can start substituting here. G of x is e to the x power times f prime of x, which is now times x prime, minus f of x, which again is x, times g prime of x, which is e to the power of x prime, and then over e to the power of x squared. Okay, now we take the derivative and simplify. So we have e to the x, and the derivative of x is just multiplied by 1. So we have multiplication by 1 minus x, and derivative of e to the power of x is just e to the power of x. And e to the power of x squared is e to x. All right, now we have e to the power of x times 1, which is just e to the power of x minus x times e to the power of x and divided by e to the power of 2x. Now we can actually simplify it a little bit further. We can factor out an e to the x and be left with 1 minus x inside the parentheses and e to the power of 2x at the bottom. One of these will cancel out. That's the one in the numerator. So we are left with 1 minus x over e to the power of x. And this, ladies and gentlemen, is our final answer. Okay, you can actually rewrite this also as e to the power of negative x. So just taking the inverse of the denominator here and multiply by 1 minus e or 1 minus x. And then you could, if you want, it just depends how your teacher or professor, how the question is really questioned and how it wants your answer to be. But you could substitute the e to the power of negative x as well. You can leave it like this. You can have it as e to the power of negative x minus e to the power of negative x times x if you'd like. Either one of these is the correct answer. All right, let's do a pretty simple one here. I'm going to come up with a random one. Let's have y equals to x squared over x plus 1. So what we can do here is say that f of x is equal to, and I'm wondering, okay, you could, no. All right, so we'll say f of x is x squared, and g of x is, of course, the one in the denominator, which is x plus 1. And then we'll use the quotient rule. So I like to always rewrite my quotient rule as g of x times f prime of x minus f of x times g prime of x over g of x squared. All right, so now we have y prime is equal to g of x, which was x plus 1, and now f prime of x, which is x squared prime now, minus f of x is x squared, times g prime of x. Our g of x was x plus 1, so we're going to prime that there and take its derivative soon. And then g of x squared is, of course, x plus 1 squared. So now we can continue. Y prime is equal to x plus 1. Now we take the derivative of x squared, which is 2x, minus x squared times the derivative of x plus 1, which is just 1. So we're multiplying just x squared times 1, and we have x plus 1 squared at the denominator. So now we have y prime is equal to, we'll distribute this 2x to both the terms inside the parentheses here on the left. So we're going to have 2x plus 2x squared minus x squared over x plus 1 squared. Our y prime is then equal to, we can combine the like terms here. This is just going to be x squared rather, plus 2x over x plus 1 squared. Now, if you'd like, you could also leave the answer by factoring out an x at the top and just having x plus 2 in the numerator and x plus 1 squared in the denominator. Either one of these two would be your answer. All right, so here we have another function. We'll use the quotient rule, of course. We have two functions being divided, so our f of x is going to equal to e to the power of x, and our g of x is going to be 1 minus e to the power of x. Now, of course, just for you to memorize, again, I get it. We don't have to always rewrite this, but just for us to get, for us to remember the power rule, or the quotient rule, I should say. There's all these different rules I'm trying to go through my head here. It's just the quotient rule, but for us to memorize it, we'll just rewrite it again. G of x multiplied by f prime of x minus f of x, This thing always has a problem with erasing. F of x times g prime of x over g of x squared. Okay, so we've already established what f of x and g of x is. Our g of x is going to be 1 minus e to the power of x. We'll take the derivative of f of x, which is e to the power of x. That's e to the power of x prime minus f of x, which is e to the power of x. And our g prime of x is going to now be 1 minus e to the power of x prime over g of x squared, which is now 1 minus e to the x squared. Okay, so now we just simplify and take the derivative. We have y prime is equal to 1 minus e to the power of x, and the derivative of e to the x is just e to the x, minus e to the x times the derivative of 1 minus e to the x is just going to be left with negative e to the power of x, and then that, of course, will be 1 minus, or over 1 minus e to the x squared. Okay, now we have y prime is equal to, we'll just distribute the e to the x to the two terms inside this parentheses here. So we're going to have negative e to the 2x, and then plus e to the x, and then we'll multiply these two terms over here on the right in the numerator. That's going to be negative e to the 2x over 1 minus e to the x squared. All right, now we could just simplify here. We're going to have e to the power of 2x, or negative e to the power of 2x, plus e to the x, plus e to the x. So these two in the numerator will cancel out. Let me just finish writing this denominator down real quick. These two will cancel out, and we are left with y prime is equal to e to the x over 1 minus e to the x squared. This is our final answer for this particular problem. So in summary, we have learned today the product rule for differentiation, and that is f of x times g prime of x plus g of x times f prime of x. That was the product rule. And the quotient rule for differentiation is g of x times f prime of x minus f of x times g prime of x over g of x squared. And this is if we have, if we're taking the derivative of f of x times g of x, and the quotient rule is if we're taking the derivative of two functions being divided. And that is the product rule and quotient rule. Make sure that you practice writing these down. The more you write it down, the better you have a chance of memorizing these rules, and the better chance you have at answering a question correctly because you know the product rule and quotient rule. But anyways, if you enjoyed the video, please give this video a like. If you want to see more videos like this, subscribe to my channel. Hit that notification bell button down below to be notified when the next video is up, and I'll see you guys in the next one.